Okay, so all of that we just talked about is to make it clear that the climate has changed a lot in the past. It's changed over and over again. And that's not, something that people are particularly concerned about. Yes, in the past, climate has been different. Um, what's really important currently is that the climate is changing extremely quickly. So, this shows the rate of temperature change over the last 1,500 years. And we see that currently the climate is changing faster than it has in a very long time. And so we can see here that we're kind of outside of the fluctuations that we've seen in the last 1,500 years. And we're on this major upward trajectory right now. So we're not necessarily concerned that the climate is changing. We're concerning that it's changing so fast we might not be able to deal with it well. And many scientists believe that anthropogenic, meaning human-caused climate change, is the most important environmental issue of our time. So let's look at this a little bit more. So this looks at carbon dioxide emissions since 1850, and we can see that it has increased exponentially. So we see the gray shows fossil fuels or carbon dioxide emissions from fossil fuels and cement. Excuse me. And I just want to point out that this is in billions of tons of carbon dioxide. So we can see it has increased a lot since 1900. And we also see land use change in forestry, which hasn't changed nearly as much as fossil fuels. Though I do want to point out that the amount of change from land use change in forestry has gotten pretty large recently compared to what it was a little while ago. But, not much larger than we've seen in other periods in time. So where do we get our measurements for carbon dioxide? The earliest data comes from an observatory on Mauna Loa in Hawaii in 1957. Initial measurements showed carbon dioxide levels have been increasing 0.5% per year since data collection began. So it was about 315 parts per million in 1958, 397 parts per million in 2011, and they topped 400 parts per million in the summer of 2016. Right now, I believe we're around 410 or so. But regardless, this is the highest level in the last 3 million years. That's a pretty big deal. That's a lot of carbon dioxide. And if this trend continues, you saw we were in an exponential curve, we could double atmospheric carbon dioxide levels within a century. So let's look at this data from Mauna Loa. This is called the Keeling curve after Charles Keeling, who is the scientist that first started taking these measurements, and they have continued to take these measurements. You can go to the website from the Scripps Institute, and they publish, you can go look, they don't have like today's carbon dioxide, but they'll have a few days ago, and certainly they'll have last week. And so you can look at what the recent measurements are and how that compares to this curve here. So as I said, we're well over 400 right now. So this only goes to about, I don't know, 2015-ish. So we're up here now. But I want to point out two things about this curve. So one, you see this steady increase in carbon dioxide concentrations. That is due to burning fossil fuels and clearing forests, particularly rainforests. Another thing that you'll notice, so that's kind of the average. So this is the black line is the annual mean carbon dioxide. So they averaged it for each year for this black line. And you'll see that this is a temperature on a 5-year mean here, tracking it. And it's been, increasing with it. It doesn't match it perfectly or anything. but it is increasing as we see carbon dioxide increasing. And then the other thing I want you to notice is this red line is the monthly mean carbon dioxide. So you can see every year it goes up and down and up and down and up and down. So I want you to think about why that might happen. And some of you that have taken 212 with me or taken sustainability with me probably know the answer to this. But it's because most of the land on Earth is in the northern hemisphere. So the ocean's doing pretty much the same. You know, there are some slight seasonal changes, but the ocean isn't having a big change over time. But in the northern hemisphere, right now, we're in fall. We're about to hit the trough of this graph for our year. So we're going to hit the bottom. And so trees have been doing photosynthesis all summer long and pulling lots and lots of carbon dioxide out of the air to make new leaves and to grow. They're doing photosynthesis, pulling carbon dioxide out to make sugars, to incorporate into their tissues, to grow and to reproduce. So that happens all summer long. And then in the fall, all of our deciduous trees lose their leaves and they stop doing photosynthesis and they sit dormant. And those leaves sit there and the trees aren't pulling carbon dioxide out of the air anymore. So during the fall and into the winter, when there's no leaves on the trees, the carbon dioxide starts going up because the trees aren't taking carbon dioxide out of the air. And then when spring happens, we get to the peak, and that's when the trees start putting new leaves on and they start pulling carbon dioxide out of the air again, and then carbon dioxide starts going down again. So this is a yearly fluctuation. If land was distributed differently on Earth, you might get a different pattern. But this is what we get because of the northern hemisphere's changes in seasons with deciduous trees. We also get less photosynthesis of our coniferous trees in winter too, but they can still do a little bit.